All right, guys, we are on to the Chapter 17 test. Chapter 17 is dealing with electricity, okay? Make sure you spend your time with it. Electricity can be confusing. I'm going to take you through this, but if you have any questions, remember, text or call anytime 6 a.m. to 8 p.m. I'm around. Just let me know what I can do for you. So, circuits. Okay, circuits is how electricity flows. So when the electricity is flowing, okay, and the circuit opens, so like you flip a switch, if it is in series, it cuts off. That's like the old Christmas lights. When it's flowing around, it flips open, it'll cut off all the lights because it's series. It doesn't have anywhere to go. Okay, if it can go backwards and forwards, that's called parallel. All right. An accumulation of excess charge is called static electricity. Okay, that's like when you rub your feet on the carpet floor and touch somebody and it pops. That's because you have been able to charge yourself through friction and add excess electrons to you. So when you go to touch somebody, some of the electrons are leaving you and going into them to ground back out. Okay, and that leads me into if you take a balloon and rub it on something and then put it on somebody and it makes their hair stand up or whatever, that is called charging by friction. Charging by friction. So that's taking the electrons off the object and moving it to the balloon. Okay. The law of conservation of charge, that's going to be like the law of conservation of energy, the law of conservation of matter, the law of conservation of mass, can neither be created nor destroyed. Okay. Conductors and insulators are similar to heat, but not exactly the same. Yes, metals will still be good conductors, but where water's not a great conductor for heat, it is for electricity. So look through those, make sure you're kind of familiar. Plastic, wood, glass, those things are still insulators, but just pay attention and go through. There's some lists in your textbook. So resistance, the way I like to describe this, resistance is kind of like friction for electricity. So as the electricity is winding through something, the more resistance it has, is kind of like if you've ever had to run with parachutes on or something doing speed training, how that resistance pulls you back and makes you work harder and it makes you sweat, makes you hotter. So it's kind of like that. The more you run, the hotter you get. So the more resistance that has, the hotter it gets. And hot is thermal, so that'd be thermal energy. The electrical force between two charged objects is going to be due to their charge. Are they positive charge, negative charge, both negative, both positive, whatever. How does an object become charged? To get negatively charged, it gains electrons. Become positively charged, it loses electrons. It cannot gain or lose protons. How do you measure electrical energy? The kilowatt hour. Remember, we talked about watts with energy. Kilowatts per hour is how we measure energy. The rate at which appliances use electrical energy, when you start, buying your own appliances and stuff, they'll have a little sign on it. It talks about its power usage. Just like the power we talked about in chapter 12 or 13. Remember, opposites attract. So if you have two charges attracting each other, it's a negative and a positive. So to have current, you've got to have a potential difference between the two cells. So for a battery, you need a difference in the positively charged side and the negatively charged side. And the negative side will send the electrons over to the positive when you connect them. Okay, so that is called a potential difference. An electrical current does not exist in an open circuit. Why not? Because the circuit is open, it can't flow. Okay, closed circuit, it's going to keep flowing around and it would have current. What are something you can use to keep a circuit from overloading? A fuse or a breaker. Okay, a fuse or a breaker. Like your car and stuff has fuses in it, and it'll basically have a lower resistance of the wire. So when it overheats, it breaks that, and then you can replace the fuse instead of burning your car up. Most of your houses, some may still have fuse boxes. I do. Most of you probably have breaker boxes. When it flips the breaker, you've got to push it back. But that's due to the resistance and to keep things from getting overloaded. Circuit breakers, they are reusable. Fuses aren't. Fuses, when they blow, you go buy another one. Know the difference in parallel and series circuits. So like if Christmas lights are in parallel and a light goes out, the rest will still light up. If they are in series and one goes out, they all go out. And never do this, but if you did have to grab a live electrical wire, like if you ever are a lineman or something like that, what do you want around your hand? You want an insulator, okay? Definitely want an insulator. You do not want a conductor around your hand. How many volts is the battery in your car? 12 volts. Some of you may have a 24 volt system. I run a 24 volt system in the diesel, but my gas burning truck's only 12 volt. So most of you are going to be 12 volt on that. How many amps does your car battery probably have? You're going to be in the 600 to 700. Okay, 600 to 700 is normally your cold cranking amps on your car. That's like, so like some larger equipment machinery, sometimes you'll do two 6-volt batteries to make a 12 volt to be able to get it to where it has more cranking amps because you're trying to turn over some of that old machinery. But yeah, most of your cars are going to be 600 to 700. So guys, once again, if you got any questions, shoot me a text. This test should be up on Google Classroom.